This video will review where to find IR peaks. As we talked about in class, when you have H, the smallest, lightest atom attached to another atom, because it's so light, the vibrational frequency is very high, so you find XH stretches in this region of the IR spectra. Again, as you increase the strength of a bond, as we go from single, double to triple, the stronger the bond, the greater the frequency. We looked at Hooke's law to describe that. So we find single XY bond stretches here, especially when the atom is oxygen, one of the atoms is oxygen and nitrogen. Double bonds in this region and triple bonds in this region. So let's explore. The first thing you want to look for is a carbonyl peak. Again, it's a beautiful peak, C double bond O, typically between 1810 and 1690, and a nice, really big peak. And there's all kinds of functional groups that have a carbonyl, a ketone and aldehyde. We'll cluster those together. And the whole other group, carboxylic acids, esters, and amides, in which I have a C double bond O, in which the C is then connected to either an O or an N as well. So the actual position of the carbonyl bond stretch varies depending on which of these functional groups we have, but we'll always look for the C double bond O stretch in this region. So let's start and see where we might find the peaks for specific groups. The carboxylic acid is really easy to find. This is the structure of the carboxylic acid functional group, and it has a really, really broad, hairy beard OH stretch in the region of 3300 to 2500. And of course, it would also have a CO stretch you can look for, and that would be in the region of 2010 to maybe 1320. So again, you can find both, in addition, of course, to the carbonyl peak, but this is a dead giveaway. Now let's look at the ester, C double bond OR. And again, we're going to have the carbonyl peak, but this time we're also going to have CO stretches. And in a way, I have two of them, here and here. There's actually symmetric and asymmetric stretches, but you'd find two stretches in this region of 1300 to 1000. So look for those if you have an ester, or again, if you have a carboxylic acid. Now let's look for an amide peak. For the amide peak, we would expect to see the carbonyl. We also have these vampire fangs up here in the NH stretch region. We have two fangs if there are two hydrogens, but only one sharper peak if there's one, and again in the region of 3500 to 3100. We have an NH bend here, but we don't have the CN stretch in the spectrum. Now let's look at the ketone, and it's going to be very similar to the aldehyde. It's going to have the C double bond O stretch, but it's not going to have any of these CO stretches that we saw before because it doesn't have one. There's really just the carbonyl peak that's the dead giveaway in this. How does it differentiate, however, from the aldehyde? And we can see that on the next slide. Again, we have the carbonyl peak for the aldehyde, but in this case we have this H right here, which show up as sort of these alligator jaws at about 2830, 2695. So you can always differentiate the ketone from the aldehyde because the ketone wouldn't have those. An analogous group is the nitro group, N double bond O stretch. It's the N double bond O. If you actually look at the Lewis structure, there's a double bond between one of the O's and a single, as we talked about. That double bond can appear over here, or we can think about it as each one having a bond and a half. So it's going to be a little bit have single bond flavor, not fully double bond character. So it's down in this direction, and there's a big double peak from the NO stretch, an asymmetric and symmetric stretch, dominating the spectra around these regions 1550, 1475, and 1360, 1290. Of course, now we have to look at carbonhydrogen stretches, and again, the magic line for us is going to be 3000. And if you have an alkyl group in which the C is singly bonded, we also call that an sp3. You can have an sp3CH stretch, and again, that's just to the right of 3000. But if I have an alkene, which I have a doubly bonded carbon, the CH stretch is just to the left, just a little bit to the left. So again, then you have to draw that line at 3000. We'll call it an sp2CH stretch. That's when carbon is doubly bonded. But now if I have a double bond, I can actually see a carbon-carbon double bond stretch, and that's in this region of the spectrum. It can be a peak, and it's much sharper, not very broad, compared to the carbonyl C double bond O in the region 1680 1640. But if there's an aromatic ring, it's in the region 1600 to 1400. Sometimes these are hard to see. Now let's look, we don't have any C double bond O's. Let's just look when there's none of those, but carbon's attached to either an oxygen or nitrogen. The alcohol is a dead giveaway. It's a very smooth OH stretch in the region 3500, 3200, the smooth tongue. But again, if we have an alcohol, we'll have an OH stretch, and we'll also have an OC stretch, so please look for that. And that's down in this region. The OH stretches is approximately 1260 to 1050. And finally, let's look at the amine. Again, no C double bond O. It's on amide. So we're going to have the sharp fangs up here again for the NH stretch, approximately 3400 to 3250. Clearly not a smooth tongue. But in addition, we're going to have an NH stretch here, and it's going to be down in this region 1020 to 1330. We might see a peak in here, which you might tend to think it's a C double bond C, but actually in this case it's an NH bend. Of course, it depends what else is on the molecule. So this is just a quick review of some of the peaks you expect to find in the IR spectrum.